Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Squarette Theory by Tomatanalet. I don't know how to pronounce that. I don't even know if it's actually Squarette Theory, but I'm assuming it is because there's a square symbol instead of an S, so it's Squarette Theory instead of set theory. Anyways, here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Digits along a pink line must form a consecutive sequence without repeats in any order. So for example, if this were a 1, this would have to be a 2 to form a consecutive sequence without repeats. And it could be that this could be a 5 and this would be 4 or 6, because then this 4, 5 or 5, 6 would form a consecutive sequence. And these are called Renban lines. So know that it's normal Renban rules here. Golden lines are Nabner lines, which if you look at it is Renban reversed, and must not contain any consecutive digits or repeat numbers. So it's essentially the opposite of a Renban line, or the reverse of a Renban line would be more appropriate. So you cannot have consecutive digits or repeats on the golden Nabner lines. So an example here could be something along the lines of, I don't know, 1, let's make this 1, 5, and 7, right? Because none of them are consecutive with any of the other digits on the Nabner line. So that's how that works. Digits separated by a black dot must have a ratio of 1 to 2, and digits separated by a white dot must be consecutive, and these are called Kropki pairs. Kropki dots, which separate Kropki pairs, actually. And if this, for example, were a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. And if this were, example, a 6, this would have to be a 5 or a 7 to make sure that the digits separated by the white dot are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the first thing that I can see target would be this, these 3 cells that are separated by black Kropki dots. We know that if there's 3 cells, which are each separated by 2 black Kropki dots between them, and they are all in the same row, column, or box, the only set of numbers that can fit are specifically 1, 2, 4 or 2, 4, 8. So this must be either 1, 2, 4 or 2, 4, 8, which means 2 or 4 is in the middle, and 1, 2, 4, 8 is here. Well, we know that 2 and 4 in the row and in the box have to be in those 3 cells. Similarly, this is 2 and 4, and this is 1, 2, 4, 8. Well, that's interesting, actually. This says we have a 2, 4, 2, 4 pair here. So one of them is 1, 2, 4, and the other one is 2, 4, 8. But we don't know which one is which, essentially. Well, 1 can't be here, because if this were 1, this would have to be 2 to be consecutive. And we already know that the 1 would have to have a 2 there be in a 1 to 2 ratio, so this can never be 1. Oops. This can never be 1. If this were 2, it would be 2, 4, 8, so this could be with 1 or 3. That's fine. If this is 4, it would be 4, 2, 1, so this would be 3 or 5, and that would be fine. And if this is 8, oh, interesting. Actually, it doesn't tell us anything there. I was thinking it did, but it doesn't. This has to be 7 or 9, right? If this were 2, this would have to be 4, 8. This could be 1 or 3, and this could be 1 or 3, and then this would be 1 or 3. So that's fine on the Renban. The remaining digits here are 1, 3, 5, 6, 7, 8, 9. But the problem is that's really broad, so that's not helpful right now. Hmm. If this is 2, it has to be next to 1, 3, and 1, 3. If it's 4 and 2, this would be 4, 2, 1. So 3 or 5 would be here. 3, 5, or 6 could be here, and 3, 5, or 6 could be here too. Okay, this can never be 1 or 2. Can never be 2, 3, can't be 3, 4, or 4, 5. So this could be specifically 5, 6, 6, 7, 7, 8, or 8 and 9 to be consecutive. Similarly here, this can't be 1, 2, cannot be 2, 3, can't be 3, 4, 4, 5. But it could be 5, 6, 6, 7, 7, 8, and 8 and 9. So this is also the same. If this were 8, it could have 7 or 9 along it. What does that tell us? I'm not really sure. This is more constrained in box 1. This is not as constrained in this box. So what happens if we do have 2, 4, and 8 here, right? If this is 2, this could be 1, 2, 4 here. But if we have 2, 4, and 8, that means it cannot be 1, 2, 2, 3, 3, 4, 4, 5. It could be 5, 6, or 6, 7. Does that tell us anything? Not particularly. Hmm. Well, No, this could be 8. Well, the interesting thing here is 2 has to be on one of these Renbans. So does 4. Oh, that's actually very interesting. Well, that would mean, and I guess 2 and 4 could be here, right? Hmm. 1, 2, and 4 is easy, right? Because all of 1, 2, 3, 4 could be here, which is possible. And then this could be any combination of things, right? But if this is 2, 4, 8, the 8 has to be separate from the 4. So this would have to be 8 here, which would mean this is 2 and 4. That's actually very interesting. Yeah, so say this is 2, 4, 8. Where are the 2, 4, 8s in this scenario and this in this box? The 8 would have to be here because it cannot be in a Renban with 2 or 4. Actually, I think the 8 would also have to be here too, right? Because at least 2, yeah. 8 cannot be on a 4-length rem band with 4 or 2, so it could not be here. So this would have to be 8, which would force this to be 2 and 4 together. And if, again, in this one, it cannot be on a Ren band here, because it cannot be on a 4-length Ren band with 4 or 2. So 8 would be in both of these. This would be 2, 4. But what are the remaining digits is the question, right? So this would have to be 8. This would be 8. This could be 2 and 4 here. Well, okay. This specifically cannot be 2. If this was 2, this would have to include 4. But then both of these, so this would be 2 and 4 here. This would have to also include a 3, right? No matter what. If this were 2 and 4, it would also have to include a 3, but then 3 could not be here or here in row 3 then. And that's not allowed because there's no 3 then in the rest of the row. So this could not be 2 and 3. This would have to be 4, 5, 6, 7, which would force 2 to be here. This would be 1, 3, and 9. And therefore, this would have to be 5, 6, and 7. So this would be 8, 9. I guess this would be 1, 2, 3. This is the only possibility if this is 2, 4, and 8. That's interesting. That actually works, though. Okay. Well, what if it's 1, 2, and 4? If it's 1, 2, and 4, well, here it cannot be 1 and 2 here. So 1 or 2 has to be here. So this 2 then, and you always have a 3 and a 4 with it. And it can be 2 through 5 or 1 through 2 and 4. I guess the 1 could be here. That's possible. Actually, let's try to see where that leads us, right? So say this was 2, 4, 8, right? So then this would have, not that one. This would be 2, 4, and 8. Well, we don't know which one's which. So this is 2 and 8, this is 2 and 8, and this is 4. Therefore, this would have to be 2 and 4 together, which means there's a 3 here. So this would have to have a 3 here somewhere. This would have to be 8. Again, the 8 could not be with the 2 or 4, so this has to be 4, 5, 6, 7, which makes this 8 and 2. This would be 1, 3, and 9. So this would be 2. This would be 1 and 4. This would be 1 or 4. This can't be 1, 3, or 9, so this has to be 5, 6, 7, which makes this 8 and 9, and this is 1, 2, 3, 4. Well, 8 cannot be here. And 8 cannot be here. So only one of these two could be an 8. The other one has to have, Renban has to have an 8. But 8 can never be on a 4-length Renban with 1, 2, and 4. And it would have to be one of them because you can only have 2 here. right? So 8 would have to be on one of these. 1, 2, or 4, only 2 of them can be here, and only 2 of them can be here. And then 8 would have to be on a ren band with a 1, 2, or 4 of length 4, which is not possible. So this is never possible then, specifically, because of the restrictions that we have. So this cannot be 2, 4, and 8. It has to be 1, 2, and 4. And we know then this specifically has to be 1, 2, and 4. So this has to be 4 with 2 and 8. This is 4. 4 is only consecutive with 3 or 5. And on a ren band with 3, 5, or 6. Well, this can no longer be 5 and 6 then, because that would eliminate 2 possibilities here, which would force both of these to be 3. So this can't be 5. It could be 6, 7, or 7, 8. This can no longer have an 8, so it can't be 8, 9. So this has to be a 6 here. It's either 5, 6, or it's 6, 7. This can't be 1, so one of these must be a 1. The rest of these cells are specifically 1, 3, 5, 7, or 9, and these can't be 1. 1, 2, 4 here. So this cannot be 1 and 2. So this must have a 2, at least a 2 here. So it could be 2, 3, 4 at least. So this has to be 2, 3, 4, and it's 1 or 5. So this is 1, 5, 6, 7, 8, 9. And this is also 5, 6, 7, 8, 9. It cannot have a 3. So 3 has to be here. Therefore, 2 cannot be here, because 2 requires a 3 on a 4-length ren band at least. So therefore, this must be 2. Where's the 1 then? 1 can't also be there, so this must be 2 and 1. This has to be 4 through 7. So this is remaining 3, 8, and 9. So these can't be 8 or 9. We have 5, 6, and 7 here then. This can't be 5, so this is 1, 2, 3, 4. Therefore, this would have to be 8 and 9, which is not allowed, period. That's problematic. Huh. Maybe that my logic previously was incorrect, because this logic is seeming even more constrained. Right? Hmm. If, again, so where is 1, 2, and 4 here? 2 and 1 cannot be on this Nabner line. So one of them has to be here. If there's a 1 here, though, the 2 also has to be here. And if there's a 2 here, there has to be a 4 here. So there's at least a guaranteed 2 here. So it has to be 2, 3, 4, which means 3 cannot be here, which means 3 has to be one of those 3. Well, this can no longer be 1 or 2 because they both require a 3. So this must be 1 or 2 here. This has to be 4, 5, 6, and 7 because we need a 4 here somewhere. That would force this to be 3, 8, and 9. But 8 and 9 cannot be on the ren band, so but they can't be on the Nabner. This is like even more of a, yeah, this is telling me that this is definitely not the way to go, and something about my logic previously was incorrect. 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 Okay. Because this is a clear cut thing that this has to be 8 and 9 then, which is not allowed by the Nabner line, right? So this is telling me that somewhere in my logic previously was something was wrong. Okay, let's restart and keep the time then. So then that's saying that this has to be a 4, and this is 2 and 8 and 2 and 8. Well, then this is 2, and this is 1, 4, 1, 4. Right? This then could be 1, 3, 7, or 9. If it's 2, this could be 4 here. So we have 2, 4, and 8 somewhere here. 8, again, cannot be on an Abner line. Oh, I see the problem that I had. It was here. This could be 2 and 4. Anyways, yeah, 8 cannot be... So we proved, going the other way, that that doesn't work, period. So this has to be 4 with 2 and 8. This is 2 with 1 and 4. Where can the 2, 4, and 8 be on these Renban lines? This specifically has to be... 8 cannot be on a 4-length Renban with 2 or 4. And 2 and 4 cannot be together on this Renban. So it would one of them would have to be here if this were with 8, and it's not possible. So therefore the 8 specifically has to be here. And this has to contain 2 and 4, which requires a 3 here. So this cannot be 3. Well, where's the 3 then? It has to be here. But 8 could actually be here. And 2 and 4 would be on this Nabner line. And that's where I ran into the problem, right? I was saying 8 has to be here, which means 8 has to be on one of these Ren bands with the 1, 2, 4. But that's not actually the case, right? 8 can be here and 8 can be here, and that's fine. 8 is no longer on both Ren bands. So this could be 2, 4. This would have to have an 8, so it'd have to be 6 and 7 at least. This is 2 and 4. 1 can never be on this Ren band. So this is 1 and 3 at least. And this is specifically 5 or 9. So this has to be 5 or 9. So we have a 1 and a 3 and a 5 or a 9 here. So 1 has to be on one of these Ren bands. Well, it can only be here. So this is 1, 2, 3, 4. 5 can no longer be on any of these Ren bands. So this must be a 5, which means this cannot be 5. So this is now a 1, 3, 9 triplet, which eliminates 1, 3, and 9 from the rest of the box. So this can't be 9. And it also eliminates 1, 3, 9 from the rest of the row. So this can't be 1, 3, or 9. So this has to be specifically 5, 6, and 7, which makes this 8 and 9. Well, 2 and 4 cannot be on this in this column, and it can't be here. So 2 and 4 both have to be on this Ren band. We know we need a 3 here, so this cannot have a 3 here. So 3 has to be in this area. Well, 1 and 2 can no longer be on the Ren band because it requires a 3 to be there, so this must be 1 and 2. 4, as the only place left, has to be on the Ren band, but it cannot have a 3, so this must be 4, 5, 6, and 7, which makes this 3, 8, and 9. This can't be 8 or 9 because of the 8, 9, 8, 9 pair in column 6, so therefore this must be 3, which means this can't be 3, this is 8 or 9. This remaining cells now have to be 5, 6, and 7, because we already have an 8, 9, 8, 9 pair and a 1, 4, 1, 4 pair, and we have a 2 and a 3. So since this is 5, 6, and 7, the only digits remaining now have to be 1 with 2, 3, and 4. So this now must be 8 and 9. This can't be 9. These must be consecutive, but it cannot be 1 and 2, so this cannot be 1. So this specifically has to be 3 with 2 or 4. So this can't be 3 because these are consecutive. So this, again, cannot be 1, 2, 2, 3, 3, 4, or 4, 5. It has to be 5, 6, or 6, 7. Either way, the 6 has to be here. Right? It cannot be 8, 9 because we can't have an 8 in one of those cells. And it has to be specifically 5, 6, or 6, 7. which means 6 cannot be here. We also have a 5, 6, 7, 8 quadruple in row 1, which eliminates 5, 6, 7, and 8. Therefore, this must be a 9. This has to be an 8. These can't be 8 anymore. The rest of the cells cannot be 5, 6, 7, or 8, so this must be 1, 2, 3, or 4, but it can't be 2 or 4 because of the 2, 8 pair and the 4 already in the box. Let's see. This has to be, again, 5, 6, 7, 8, or 9, and any of those work. But 8 and 9 specifically doesn't work because that would eliminate all possibilities for that cell. So this cannot be 9. We also know this can't be 3. So where is the 3 in row 9? It has to be here. So this is a 3. That's 3 in the corner. We celebrate. The remaining digits on the Nabner line, well, you can't have a 4. So it has to be 2 out of 5, 6, and 7. Well, if you have a 6, obviously none of those work, so this must be specifically 5 and 7. So this is 5 and 7, which eliminates 5 and 7 from the rest of the row because it's a 5, 7 pair, which makes this a 6, and therefore that's a 4 that's left over. This 1 to 2 ratio, This 1 to 2 ratio cannot be 4, so it can't be 4, 8, or 2, 4. So it has to be 1, 2, or it's 3, 6. This, if it's 2, would have to be next. It cannot have a 4 on this Renban, so it would have to specifically be 1, 3, and 1, 3. But then this 2 would be consecutive with another 1, 3, and there would be 3 1, 3s in box 1, which is not allowed because there's only 2 digits in 1 and 3. So this can never be 2. This must be 8, which makes this a 2. This can't be 8. So this 8 is next to a 7 or a 9. And this has to be 6, 7, or 9 to be on the Renban, right? Because it could be 8, 7, 6. This would also be 6, 7, or 9, but 7 cannot be here because we have a 5, 7 pair already in the box. So where is the 7 on this Renban, which it does require, right? 8 on a 3-length Renban has to be either 7, 8, 9 or 6, 7, 8, but both require 7. So therefore, this must be a 7. This has to be a 9 then, and this cannot be 5, 6, 7. It has to be 5, 6. This is 1 or 3. This can't be 3 because of that 3, so this must be a 1, which makes that a 3. This can no longer be 3 here. This can't be 1. This can't be 7, so this is 5 or 6, which means this can't be 5 because of the 5, 6 pair in the box. 3 cannot be on an Abner 9 with 4, so this must be 1. So these can't be 1. What's this Abner line? It has to be 3, and what's the last digit? It cannot be 6 because 5 and 7 are both consecutive with it, so it must be 3, 5, 7, which forces this to be 6, which means this can't be 6. This cannot have a 3, 6 pair because we already have a 3 in the box, so it's either 1, 2, 2, 4, or 4, 8. These are consecutive, but you cannot have a 3, a 5, or 7 there because of the 3, 5, 7 triplet in the box. So it's either 1, 2, or 8, 9. Oh, that's interesting. This is 6 or 9 here. Where is the 8 in column 4? There's only one place. It has to be here. So this is an 8, which makes this a 9. Where is the 9 possible in column 4? It can only be now here because the 8 eliminates this possibility as a 9 here. So this is a 9. Where is the 9 possible in this row? It can only be here. And in addition, we have a 1, 2, 4 triplet in row 9, which eliminates 1, 2, and 4 from the rest of the row. This can't be 4 then. Where is the 8 in the row? Also, it has to be here. So this is 8, which forces this to be a 7. Well, now this has to be a 5, 6 pair, which eliminates 5 and 6 from the rest of the box. So this has to be 4, 7. This can't be 4. This has to be 2 and 3 specifically, which makes this a 1, and that, therefore, this is a 2. And therefore, this can't be 2. This can't be a 1 anymore because of this 1, so this must be a 4, which makes that a 1. The remaining digits here are 5, 6, and 9. This has to be an 8. This can't be 9. This cannot be 9. The remaining digits here have to be 1, 2, 3, 6, or 8. So if this is 8, 9, this has to be 2. So if this is 8, 9, this has to be at least 2 with 1 or 4. What digits can this be? Okay. Can you ever have a 6 and an 8 on this Renban? No, because it would have to be with a 1, 2, or 3 there. Could you have a 3 and a 6 on this Renban? No, because you would have to have a 2 or an 8 included. And that doesn't form. 3 has to be 3 and 6 have to be with 4 and 5 specifically, and neither of these can be 4 or 5. So it cannot be 6, 8 together. It cannot be 3 and 6 together, so it must be 1, 2, and 3 here specifically. So this is 1, 2, and 3. Well, on 1, 2, and 3, that eliminates 1, 2, and 3 from the rest of the box because we have a 1, 2, 3 triplet. So this must be a 6, which makes this an 8. This 6 means this has to be a 3 to be in a 1 and 2 ratio with it. Therefore, this can't be 3. This is 1 and 2. Therefore, these pairs cannot be 1 or 2 to add up to, because that would eliminate all possibilities for that cell. So this has to be specifically 8 and 9, which means the 2 does have to be here, which means this can't be 2. So this is 3, which makes that a 2. This has to be a 4 to make a Renban with 1, 2, and 3. This is 2, so this can't be 3 anymore, which makes that a 9, which makes that 3. This 9 means this has to be an 8. These can't be 6 anymore, just 5 or 7. This 1, 2, 1, 2 pair eliminates 1 and 2 from the rest of the column, so this can't be 1 or 2. So therefore, that's a 4. This can't be 1 or 2 or 4, so this must be 3. This then has to be 1 and 2. And this can only be 1, and this can only be 2. So this is 2. This is 4 by normal Sudoku. This can't be 4, so this is 7. This is 4. This can't be 6 by that 6, so this must be 5, which makes that a 6. This 7 means it has to be 5, which makes that a 7. Let's see. We know one of these cells is a 2, so it's either 2, 5, or 6. This can't be 6. So one of these two cells is a 2. So in box 4, the 2 has to be in rows 4 and 5. In box 6, the 2 has to be in rows 4 and 5. So there cannot be a 2 in the rest of the cells in rows 2 and 5. So this 4 and 5. So this can't be a 2. This has to be a 1, which makes this a 2. This can no longer be a 1. This has to be a 9. So this has to be a 1-6 pair. And this can't be 1, so this is 6, which makes that a 1. This 6 means this can't be 6, so this is 5, which makes that 6. This 5 and 6 means this can't be 5 or 6, so this is 9. This can't be 6 or 9, so this is 5, which makes that 6. And this 6 means this cannot be a 6. So this is 2, 5, 2, 5. We have... This can't be 8, so this is 7, which makes that an 8. This 7 means this can't be 7, so this is 5, which makes that 7. This 5 means this can't be 5, so this is 6, which makes that 5. And now we're just doing Sudoku. We have 1, 4, and 6 left. This can't be 6, so this must be 6. Well, where's the 1 now? It has to be here. So this is 1, which makes that 2. This can't be 2, so this is 5, which makes that 2. This can't be 5, so this must be 7, which makes that 5, which makes that 7. This can't be 5 or 7, so this must be 3. This can't be 3 or 7, so this must be 5. This has to be a 4. And we have 8 and 9 left. This can't be 8, so this is 9. This is 8, and this is just all normal Sudoku, which forces this to be 3 and this to be 7. This can't be 1, so this must be 4, and that's a 1. Apologies for the earlier assumption I made that 8 had to be on this. I don't know why. I thought 8 had to be on this Nabner line. It was just a bad assumption there. Fortunately, I was proven wrong because I couldn't get through the actual other way. And it was very quickly that I was proven wrong. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.